we are going to be doing 5.3 day 1, solving trig equations. And you're going to want a unit circle handy for this. I'm going to be using a unit circle that we're going to be creating this week on a graphic organizer. Okay, so solving trig equations, you're going to solve them just like you would a regular equation. We're going to first solve for the trig function. So let's take a look at number 1. We have 2 sine of x minus 1 equals 0. So I'm going to solve for the sine of x, and I'm going to do that by adding 1 to both sides first. And then I'm going to divide by 2. And now we're going to solve for the angle. So how we're going to do this is we want to know what angle, because that's what our x is, gives us 1/2 for sine. So I'm going to look at my unit circle here. And on the unit circle, I'm going to look for all the spots where the y, which is sine, is 1/2. So the first time that happens is pi over 6. And it also happens over here at 5 pi over 6. So between 0 and 360, I've got 2 times where sine is equal to 1/2. So I'm going to write those down. Pi over 6 and 5 pi over 6. Now, because sine repeats itself every 360 degrees, I could actually have an infinite amount of answers. So in the next 360 degrees, I'll have 2 more answers, and so on. So how we're going to write that is because we have an infinite amount of answers, but they repeat every 360 degrees, is I'm going to put a 2 pi n after both of my answers. And that will make up for all of the answers for every increment of n. So you could add 2 pi, you could subtract 2 pi, because n could be positive or it could be negative. Okay, let's try number 2. So number 2, we have a little extra part here. It says just from 0 to 2 pi. So that means I don't have to add the 2 pi n to it. I just want the answers on the unit circle. So one thing we can do with number 2 is we can combine like terms. So I'm actually going to move this sine of x over to the other side. That gives me 2 sine of x plus root 2 equals 0. Just like if you had x plus root 2 equals negative x, you would move the x's together first. Okay, so now I'm going to solve for sine. I'm going to subtract root 2. And then I'm going to divide by 2. So sine of x equals negative root 2 over 2. So I'm going to look at my unit circle now again. And I want to know where all of the y values, which again is sine, is equal to negative root 2 over 2. So that would actually be down here at 5 pi over 4 and at 7 pi over 4. And since I just want the answers between 0 and 2 pi, I'm just going to write those 2 answers down. 5 pi over 4 and 7 pi over 4. Okay, moving on to question number 3. So number 3, I'm going to solve for tangent this time. So first thing I'm going to do is add 1 to both sides. And divide by 3. Now this time I have a square in my function. So to get rid of a square, we take a square root. And when we have a square root, we also have a plus or minus. And I'm going to simplify this a little bit. The square root of 1 is 1 over the square root of 3. Now on the unit circle, we don't have tangent, but we do know that tangent is equal to sine over cosine. So I've got to think to myself, where is sine over cosine 1 over root 3? So if I look at my unit circle, and it could be positive or negative, so 1 over root 3 would take place at pi over 6. And then negative 1 over root 3 would take place at 5 pi over 6. Now, tangent repeats every 180 degrees. So I don't have to go in the third and fourth quadrant because here's where tangent occurs from 0 to 180. Then it repeats itself again and again and again. So I'm going to just write the answers down from 0 to 180, and then I'll add something to it to show all of the possible answers. So we've got pi over 6 and 5 pi over 6. And to show that tangent can have an infinite amount of answers and that it repeats every 180, I'm going to add a pi n to both of these. And that adds in all of the extra answers that you could possibly have. Okay, moving on to question number 4. Okay, now question number 4, we have cotangent times cosine squared equals 2 cotangent. Okay, so we have two trig functions here. Now, normally that makes it a little tricky. So what I'm going to do first is move everything to one side. I'm going to subtract the 2 cotangent of x over. And what I notice on the left side now is that I can take out, both of these terms have a cotangent. So I can take out a cotangent, I can factor it out, and I would be left with cosine squared minus 2. Now normally when we factor and we want to solve, we set both parts equal to 0 and solve. So I'm going to set cotangent equal to 0, and I'm going to set cosine squared minus 2 equal to 0. And I'm going to solve these separately. Now, this one's pretty much done. Cotangent is equal to 0. So I want to think to myself, on the unit circle, where would that happen? So I do know that cotangent is equal to cosine over sine. So where would I have cosine and divide by sine and get 0? So it would have to happen at one of the spots where I have a 0. And cotangent, just like tangent, repeats every 180. So I only have to worry about the first and second quadrants. So if I divide cosine by sine and I get 0, that would happen right at the top here at pi over 2. So x would equal pi over 2. And I'm going to add a pi n to that. Now over here, I'm going to add 2. And I'm going to take the square root. And that would give me plus or minus root 2. Now, on the unit circle, there's actually no spot where cosine would equal root 2. If you think about it, root 2 as a decimal is 1.414. So let me write that down. The unit circle does not extend past 1, so therefore, this can never happen. And if you tried to do this on your calculator, you would type in inverse cosine, so second cosine of root 2, and you would not get an answer. You would get an error. So this does not exist. So we've only got one answer that works. Now, if you want to check your work, you could take this pi over 2 and plug it into your calculator, plug in the left side, get an answer, then plug in the right side and get an answer, and those two answers should equal each other. Okay, so another type of problem we're going to look at is sometimes you might have to factor to solve. So let's look at number 5, and I'm actually going to write this as a regular problem with just x's, so you can see how we would solve this normally. So normally I would say I would have to factor this. Now if you don't remember how to factor with a number in front, you might have done the 4-step method, or you did guess and check. If you did guess and check, you can just skip right to the answer. If you did the 4-step method, then you're going to want to follow along here. First step is we multiply the first and last number. So x squared minus x minus 2. The second step is we factor. Factors of 2 that subtract to give us 1. Third step, we put our 2 back in. And then our last step, we reduce. Now we're going to do the same thing, except for we have a sign. So instead of writing x minus 1, 2x plus 1, we would write sine x minus 1 and 2 sine of x plus 1. So I've got this all factored. I'm now going to solve. So I'm going to set each part equal to 0 and solve. So over here, I'm going to add 1. That gives me sine of x equals 1. And over here, I would subtract 1 and divide by 2. Now I'm going to go to my unit circle. So we've got sine, so it can be anywhere between 0 and 360. So first I want to know where sine equals 1. So sine is the y. Sine equals 1 at pi over 2. And I'm going to add a 2 pi n to that. And I also want to know where sine is equal to negative 1/2. So looking at my unit circle, sine is the y. Sine would equal negative 1/2 at 7 pi over 6 and also at 11 pi over 6. So I'm going to write those down as well. 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. Okay, so you're going to now create your graphic organizer. Some of the questions are going to be repeats of the ones that we did today. I quickly go over how to do them in the graphic organizer, so if you need a little refresher, you can rewatch those. And I also show you how to put the graphic organizer together. So you're going to be doing the graphic organizer now after you've completed your part 1.